and all the Mango staff. You guys have been doing an incredible job today. So really kudos to you guys. And so yes, again, my name is Matt Dancho. Today we will not be talking about time series. We will be talking about HR analytics using machine learning to predict employee turnover, which I think is a pretty big problem that a lot of organizations share. So first off, before we get started, a little bit about myself. So I started using R, well, put it this way, I've been doing analytics since about 2011 with my first kind of thrust into a management role. And since then, I quickly learned that Excel breaks, when you get to a certain data size. So out of necessity, I needed to find some new tools. And so probably in 2011, 2012 timeframe, I stumbled across this programming language called R, and I really haven't looked back since. It's really been something I'm passionate about. It's something that I get excited to use and to talk about and to educate. With that said, a little bit about business science. I want to go over what we do. So there's really two kind of clusters of interest in business science right now. The first one is on the consulting space. We primarily work with executives, and where we add value is, well, number one, we do data science, so we're like their bolt-on data science team. But what we really do is work with them to provide machine learning, leveraging the strengths of machine learning, which is making predictions, analyzing massive quantities of data, and we'll talk about this today, but really providing insights to the executive team. And then what leadership is really good at is then taking those insights and then deciding what to do, right? So what we found is if you give executives really good data and really good insights, they can kind of, they tend to make very good decisions then. So that's the one area that we help out. And then also, our, as you're probably very aware, is a community-driven programming language. I've never seen anything like this, to be quite honest, where you don't see it with Python, you don't see it with a lot of the other languages, where there's really a concentrated group of individuals that all care and are deeply passionate about it. So what we like to do is educate data scientists. I don't know if you guys are familiar with business science, but we have a blog, and we give away a lot of free information. Really, it's one of the ways that we give back to the community. The other way is some of the packages. So just quick show of hands, how many of you are familiar or have ever heard of Tycoon? Okay, pretty good, pretty good. How many of you have actually used Tycoon? Okay, slightly less, but still pretty good. Well, for those of you that are familiar and or have possibly used it, I do have a couple of stickers left if you guys want. So after, free swag, guys and girls. Open source software, another way that we like to give back. Tidyquant's the main package, or the most popular. It's with financial analysis in the Tidyverse. Then there's also TimeTK, that's for time series machine learning. There's Sweep for tidying Rob Hinman's forecast package, the forecast workflow. And then the most recent one is Tibble Time, right? It's Tibble Time. So what that is a special time series, time-aware class that rests on top of RStudio's Tibble package. And it actually allows us to do a whole slew of complex time series analysis without actually having to convert back and forth between XTS and Zoo. It's all available in the Tidyverse, and it's really cool. So last thing on education, if you are a data scientist, we really want to focus on you in 2018. We're developing some courses with Data Camp, and we have Tidyquant, which should be available here end of the year, and then we're looking at several courses for next year, focusing on some specific applications. Okay. All right, so because this is a business conference, we're going to talk a little bit about the executive side of the business that we focus on. So executive leadership, what we have done is really taken a look at it from 3 different levels for providing a service to customers. So education, that's the first one. The executive leadership team typically needs to be educated. So we focus on significant problems and try to get them to understand, how data really fits into that picture and how machine learning can help, and also things like that you need to think about, such as risks. What happens when, over time, a model tends to break down or things change? What are you going to do? So that's the education piece. You also have data management, so that's the next phase of it. So once you get them educated, you really need to then start working on data. So typically most organizations have a lot of good internal data, some of it not so good, and then there's also this World Wide Web, right? So we've got external data. And what we found is you really get good results when you blend the two together, and you can get interesting insights and provide that to the executive leadership. So it's really building that data management process, and will help facilitate that as well. And then the last piece is also critical, is data science. So it's how can they benefit from machine learning? How can we implement that within their organization? How can they distribute it to the key stakeholders and decision makers? And then lastly, how can they make those decisions using machine learning insights and things to do, things not to do? Okay. So what we've developed is a systematic approach. It's a systematic process. It's adaptive. So it starts with learning. We need to learn the business, we need to learn their system, and in order to be able to then go into that next phase, which is modeling that system. So we spend a lot of time up front trying to digest what they've got going on, what they're currently doing, and using that as a baseline for future model development. Once we build that model, then it goes into the third phase, which is actually implementing machine learning and predictive analytics in order to gain those insights. But then you're not done. It's a cycle. So what tends to happen is we look at things like cross-sectional data, and we don't think about things like, time. Things are going to change. So it's really that continual learning process, really working with them to understand that, hey, just because we've got a good algorithm now, 6 months from now, it might not be as good. We've got to do something about that. What we've really seen, though, is, and this is really cool, so once you've developed the systematic process, you can really apply it to almost any problem. So while the problems are all different, the system is the same, and it's really trying to understand and really follow that path, that cycle. So this means that we can apply this approach literally to HR, we can apply it to supply chain and logistics, we can apply it to finance, really anything. Okay, so that's enough about business science. Thanks for listening to me. We'll get into what we actually all are probably here to listen about, which is HR analytics. So we're going to be talking about predicting and explaining, because both of those are those two are key to the business. So predicting and explaining employee turnover. So three reasons you should listen to this talk. First, employee turnover is a huge problem. Second, predicting and explaining is very important. We're going to go over some tools that you can actually use and implement in your own organizations. Third, we're going to give you some of the secret sauce. We are going to literally provide you the framework that I use for performing machine learning in business applications, or one of the frameworks that we use. Okay, fourth reason, we're not done yet. It's popular. So this talk is actually based on an article that was on our blog. It went viral. So we got about 800 LinkedIn shares. It was featured on our bloggers, KD Nuggets, LinkedIn. You can get to it. So all the code that we're talking about in this talk, you can get online on our website. It's at this URL, but don't worry about the URL. If you just Google predict employee turnover, it'll pop up as the first hit. Okay? So not a whole lot of memorization. Predict employee turnover. 3 things that are in the title of this presentation, right? Okay. Employee turnover, it's a huge problem. So this quote from Bill Gates, I think really cuts to the core of this thing. So he says, you take away our top 20 employees and overnight we become a mediocre company. So what is he saying here? He's saying that those 20 employees that are highly productive are part of Microsoft's competitive advantage. This is hugely important, and the implications really can affect the business if you lose these productive people. So the costs of turnover are huge, yet it's also often undiagnosed because many of these costs are intangible. And I say intangible, but that doesn't mean that we can't assign a cost to them. We don't get that into this, into that level of detail in this presentation, but it is something that we can do using assumptions and really showing the organization the true cost or an approximation of that to the organization. But so what do you lose when you lose a productive employee? Well, you lose a lot of things. You lose new product ideas, you lose great project management, you lose customer relationships, and you lose many more things that are key to that competitive advantage. So, a couple of things that we're going to talk about in this talk, and this is stuff that I'm really excited about. Just so you guys are aware, these two packages, H2O and LIME, are two of my favorite packages out right now for machine learning. I don't have any affiliation with either of these two packages. Well, I do have a little bit with the guy who maintains LIME. We'll get into that, but really, I'm only here telling you this based on my experience, but these packages are the real deal, and it's something that you guys should definitely investigate. First one's H2O. We're going to talk about automated machine learning, which is brand new. It's not actually released on the CRAN version, so you have to go onto the website, but it's really good for very quickly and efficiently predicting at very high accuracy. Now, the downside with it is it typically will return a model, or many times it will return a model that is highly complex and therefore unexplainable by traditional approaches. So the second package solves that problem. So LIME is a brand new package. It was developed originally in Python, but then ported over here recently to R. And it's used to explain machine learning classifiers. So things like deep learning models, stacked ensembles, random forests, all of these models that traditional approaches, you couldn't get feature importance, well, you now can. Okay, so the problem, the data. The data that we're using in this talk is publicly available. It was developed by the IBM Watson team. And because most HR data, most companies just aren't willing to give it out for free, it's typically private. I do want everyone to be aware, it is a simulated database, but it's actually a really good representation of what a real world database in the HR space, like something that you might pull out of a program like Workday, it really approximates that very well, and you'll see that with some of the features. And it was developed by IBM, so they do a lot of consulting in the HR space. So their team is obviously going to be very proficient at making a data set that approximates what actually happens in the real world. In fact, it was even used for an IBM Watson case study, which we had a target on. So goals, that brings me to goals. First goal, we wanted to beat this, 85.6% accuracy for the IBM Watson model. So the first goal was to improve on that predictive accuracy. We basically said, hey, we're competitive people, we want to try and win. We took it as a nice challenge. The second one is because of the business. Most businesses, they want to understand not only what's going to happen, but why is it going to happen? So because then they can pull on the levers and be able to kind of drive the ship, right? So the other piece of this is that we wanted to do a good job explaining the features that drive the model. Okay? So the feature set. This is that IBM Watson data set. Again, it's an HR data set. It has 35 features consisting of things like age, attrition, business travel, their wage, what department the employee was in. So the target was attrition, and every other feature was used to basically develop our model. There was 1,470 observation, and each observation is an employee. Okay. So modeling with H2O. This is super cool, and this was like so easy for just to pick up, because really prior to developing this blog post, I didn't have any. I had a little bit of experience with H2O, but not the automated machine learning, and this made it super simple. Okay, so using this H2O auto ML feature, what it does, or excuse me, function, what it does, so we split it into a training set, a validation set, and a test set. Test set's unseen, validation was used for validating, and then training was how we built the model. So it was 70% train, 15% validation, 15 test. And we just plug that right into this H2O.AutoML function, and it assigns, or it basically uses all of these cool models like deep learning, stacked ensembles, gradient boosted machines, all of these advanced techniques on that data set, and then it gives you a leaderboard or a list of models that are ranked by the validation set or the leaderboard frame, basically, so you can just pick from which one you want, and typically you'll just take the top of the list, right? The highest accuracy. So that's what that function actually does. Then what we did with it was we predicted on the test data set. Right out of the box, this thing was super accurate. So 88% accuracy, if you remember the goal, 85% accuracy was what IBM Watson had. We got 88% right out of the gate. Okay, so accuracy is cool for our goal, but for the business, what we really care about is recall. So we'll talk about that on the next slide. And then the last thing I want to point out is this thing called the null error rate. So that's just if we picked for everyone the majority class, which happens to be not turnover. So if we just said no one turns over, we would get 79% accuracy. So this means that the model is actually doing pretty well. You can also do things like measure the AUC area under the curve, or the ROC visualizations. But really, 87% accuracy or 88% accuracy, it's doing a pretty good job. And that's actually not bad for HR type data. Okay. Implications to HR. Recall, 62%. So what this means to that HR group is that they now have a model that potentially can pick out 62 out of 100 times correctly who's going to be more than likely turning over. So this means that they can do all sorts of things like try and get in touch with those people preemptively, and really try and see if they can solve some things and really target those people to try and retain them. The other thing is precision. So typically in these types of analyses, precision isn't as important for this particular problem, but it's certainly something that you don't want to just let precision drop off the map and fully go down to zero. So 54%, that was acceptable in our eyes. Obviously, you can do some other things too, some more sophisticated stuff to really optimize this model for both recall and precision. Okay. So we've got a great model using H2O, but how do we prevent turnover? Okay. Turnover is easy now because we have this thing called LIME. It stands for Local Interpretable Model Agnostic Explanation. So the theory behind LIME is that it takes a model, these complex deep learning models, which are nonlinear, and it approximates them locally and discretely as linear models. Okay, and it does this over and over again. Typically, the default is 5,000 permutations, and what that means is that it outputs the features progressively that tend to be more important to these local models. Okay. So the result is that data scientists can actually understand why these models predict what they predict. So this in turn, the end result is complex classification models, such as black box models that are traditionally not explainable. Things like neural networks, ensembles, random forests, they can now be explained. And as of here recently, just a few weeks ago, H2O and LIME are now integrated, meaning if you follow the post, we actually had to come up with some special functions to link them all up. But we've since got those functions integrated into LIME. So Thomas Lynn Peterson and I worked on that to get that pushed. So as of now, if you download the GitHub version, you're all set up to go. Okay, so how does LIME work? Step one, what you do is you use code that's similar to this. You use the LIME function, and it creates this thing, we call it an explainer. You then take that function, and it creates this thing called an explainer object, and you pass it to the explain function along with that test data set. So there's a couple other things that you need to be aware of. Probably the most important one is this kernel width, because each of those local models have an R² value that you want to try and maximize. So you can adjust that to get your optimal level. Okay, so this creates an explanation that you can then send to this next function called plot features and output this handy feature importance visualization. So this is how this thing works. We set it up for the top 4 features, and it's so for each case that you pass it, it'll give you these bars that basically suggest how important that feature is to the model. And so things like overtime equals no was very important to this being classified as no at this particular case. So really, if you look at a bunch of these cases, you can kind of pick out which trends seem to be more frequently having higher influence on that model. So then what you can do is do some further investigation, and we did it for this particular data set. We saw that overtime was one of the most consistent things in this model, one of the consistent features that had some influence. So we analyzed that one specifically. And what you see here is on the bottom, the x-axis, it's no and yes for attrition. So no, obviously a lot more people are not turning over. And then on the y-axis, there's 0 and 1. So 0 is overtime. It means not very much overtime. 1 means they're working overtime consistently. So what we can see here clearly is that from this visualization that LIME told us this is an important feature, you might want to check it out. We checked it out, and there's a very high proportion of the overtime folks that, the non-attrition folks that are not working overtime compared to that attrition class. Okay. Same thing with job role, different visualization, but basically looking at how attrition, the proportion in each of these subgroups within job role. And we can clearly see that at the top, there's sales representative. They're turning over at almost 40% rate. And you compare that to some of the other ones that are not attributed or not turning over, like manager and research director, which are like 4 and 5%. So there's definitely a relationship there with the job role. Okay, so this is great. It's fine and dandy. It's a fictional data set. How does this relate to the real world? Well, it's kind of funny. We actually did this article to try and win a client. A Fortune 500 firm came to us, and we wanted to really go over and above and just to try and reel them in. And so they ended up working with us, and we applied a very similar type of analysis to, instead of employee turnover, executive potential. So this is a list that employees get put on. If they're super high performers, like top of the top, they get put on an executive list. So what our algorithm did was it identified 16 employees that were predicted as executive potential, but were not currently being targeted by that client. So this is type 1 errors that are super important, because now we're giving them a list of individuals that the algorithm thinks they should be on an executive list, and were talking with their executives saying, hey, you might want to check these guys out because we could be missing something. So real world applications, it's not just useful for this blog post. Conclusions, we can use predictive analytics and machine learning for HR. We predicted turnover, we had 88% accuracy. The recall was actually the most important thing here, and we had 62% on our test data set. Also, we can explain black box models, and we saw in this talk that turnover tended to vary for this particular problem based on job role and overtime. Also, what you saw was a framework for high accuracy and high explainability. So we're done, right? No. There's things called risks, or things that we need to be aware of, because you got this great model, you got this nice explainability. You release that into the wild, and you just think you're good to go. There's some other things that you really need to think about before just jumping right in, such as, how do we know this model is right? We haven't back tested it, or we looked at a cross section of data, but this is time independent. What happened in the previous time frame, and the other, if you extend that back, and it's very common in like financial analysis to do that type of testing. So we recommend that be done here too. What about when the model breaks down? So ideally, you don't want to let that happen. You want to keep iteratively taking a look at that model. Maybe not every day, but once a quarter or once every 6 months, to make sure that it's producing the results that you originally intended. So the only certainty here is that change is inevitable, especially in business data. So things you need to keep in mind. And that's where business science comes in, because not only do we help you build these nice models, we also make sure that they continue to run and make sure your executives are using them properly. Okay? So business science, just to wrap it up, our client archetype, we are seeing clients that are in need of predictive analytics to understand business problems as systems, to increase profitability, make better decisions, mitigate these risks with data science and the preemptive iteration, and also conveying insights to stakeholders. So, and the beauty of this model that we have with business science, that is that you don't need a data science team. We can be extended as your bolt-on data science team. Okay. All right, so that wraps it up. That's what I had. Hopefully you enjoyed it. Does anyone have any questions? I saw your hand first.
That's an interesting interaction between LIME and the other predictive models. It looked to me like LIME is using that Bayesian technique. Can LIME stand alone and just do the analysis?
No. LIME is it's meant to not be your machine learning algorithm, but it's meant to help with those classifiers. So basically what it does is it takes that model, runs your model many, many times to find out those linear. So you need to have a model to start with as the input. Does that make sense?
It does. It almost seems like it's duplication of work.
It's doing something differently. So when you're modeling, you just want to get a yes, no answer, or a regression, a value out. When you have a complex model such as deep learning, though, that's providing those results, you really need something that is able to help with that feature importance, because you can't get a feature importance plot out of like a deep learning model. At least I'm not aware that you can, except for with an approach like LIME, and that's what it's designed to do.
It's interesting.
Is it regress on the predictors? That's basically what it's doing around the sort of.
Very. From what I understand, and again, I haven't dove into the full algorithm behind it, but from the videos that they have online, and from just in working with it and reading the documentation, basically it's a very small like linear model. So it's a subset of the feature, the space that you're, of the full model. And that's why they call it local. They're looking at it locally. So that way they just fit like a linear regression and look at the predictors that are most influential to that linear regression.
It's a permutation analysis.
Okay, okay.
Yeah. So they're doing it like 5,000 or 10,000 times.
Sure,
depending on
yeah,
what-
it sounds like a kind of boosting technique, right? So,
Yeah.
okay, any other questions? Yeah, back there?
Quickly, the 16 people that you identified as high potentials that the executive did not, was there something, like when you explained that to them, were they like, oh, these people, we didn't consider these people because of X, or was there some kind of
Yeah.
implicit bias that they had, or
So
without getting into like?
Yeah, unfortunately, because we had a confidentiality agreement, I can't tell you like what the specific features are that were important to that particular client. But we did have, it actually paralleled this analysis very similarly. And we gave them a list of features that they need to look into, or that could be, reasons that, they're being flagged as executive potential.
When you're looking at like, going back to the plot that you had, overtime versus not overtime and attrition rates, would you, when you were like giving advice to an executive, would you put that as something that is causal, or would you, like, what would be the next, how would you phrase that to an executive saying like, you shouldn't have them work overtime, or do you think that's correlated with like just their mentality?
Yeah, it's tough because, just because the line, like, it's not necessarily saying that this is what's causing, in statistics that's very difficult to do, right? You can't, correlation isn't necessarily causation, but I think what you can do is say, hey, these are features, these are things that are going on within your employee population that you might want to take a look at. Again, it's always fun working with execs because they're really smart people, but oftentimes they can be very opinionated as well, and you have to kind of let them see the data and then hopefully get the conclusion that you think it is.
I guess my like follow-up question would be, when you if you presented something like that to an executive, would they come back to you and say like, does that mean we should stop giving overtime? And like, because that doesn't seem like, if I showed an executive that graph, that would not be what I wanted them to get out of it.
Yeah. So when it comes to overtime, I think there needs to be a work-life balance. So that's something that's very, obviously, a lot of companies preach it, but you want to make sure you follow through with that, and that's maybe a way that you could potentially suggest it. You don't say, obviously the business is important, it needs to run, and you need to continue to, otherwise everyone's out of a job, and that doesn't help anyone. So it's really just trying to make sure, look for these situations maybe that, like for instance overtime, if people are repeatedly putting themselves in that situation, maybe you need to add another person, or maybe you need to talk about how to restructure their work a little bit better.
Cool. Okay, thank you, Matt. That was fantastic.